Hello, I'm Luke Archer. I'm a drive systems engineer for MKE Engineering Group. We are an authorised value provider for ABB and we are based in Sittingbourne, Kent. Harmonics happen as a result of connecting a diode rectifier to an electrical supply. The supply is distorted as current flows through the diodes. The distortion is a set of sine waves that build together to form the overall distortion. These sine waves are the harmonics, and are typically frequency multiples of the fundamental supply waveform that they come from. Harmonics are caused by non-linear loads on the network, such as fluorescent lights, computers, welding supplies, and variable speed drives. They may cause equipment to behave erratically and waste energy. Motors can overheat or get noisy. Meters give false readings, lights may start to flicker, and cable insulation can break down. Even if none of these symptoms are experienced, users still have to comply with the regulations regarding maximum harmonic content on the network to ensure that other users are not affected by any harmonic waveforms generated. In the case of drives, there is reason to be extra careful as an individual site can have many of these installed. When adding further drives to a site, the total harmonic load should always be considered. Most drives have 6-pulse diode rectifiers, which give relatively high levels of total harmonic distortion, about 40%. 12-pulse rectifiers were introduced some years ago, which reduced the total harmonic distortion to about 12%. However, active front-end drives are now common. These have a total harmonic distortion of only 2 to 4%, providing a fit-and-forget solution. With an active front-end drive, harmonics are dealt with inside the drive and never enter the network. This contrasts with the traditional solution, which is to filter out harmonics after they have been created. A typical solution can be a low harmonic drive. This drive has no need for complex multi-winding transformers with 12 or 18-pulse drive configurations traditionally needed to control harmonics. Passive or active external filtering devices are avoided, making the solution compact and simple. And with a total current distortion of less than 5%, it exceeds the requirements set by international standards, even in the weakest of networks. As opposed to multi-pulse solutions, the drive needs no transformer, so there's less cabling, floor space, and installation work on site. The drive achieves its harmonic reduction by using a switching rate substantially higher than the network frequency, which effectively reduces the low frequency harmonics. At the same time, the need for over-dimensioning of power plant and distribution network capacity is reduced. More efficient utilisation of energy and reduced losses not only cut power costs, but also help preserve the environment.